Okay, and now we should be synced with all three tracks, the video 2, and the audio, I hope. Okay, so what are we talking about today? Today we're going to tackle a topic that I actually really struggle with as an educator every single year. Multiplying by negative numbers. The actual process of solving multiplication problems with positive and negative numbers is simple enough, but there's something about it that is counterintuitive that confuses a lot of students. Okay, now when multiplying in this video, I'm going to be using parentheses, okay? These are parentheses. These mean
multiply. Every time you see this, you multiply. A negative times a negative equals a positive. A negative times a negative equals a positive. Say it. A negative times a negative equals a positive. Say it. A negative times a negative equals a positive. Again. A negative times a negative equals a positive. A negative times a negative equals a positive. I can't hear you.
A negative times a negative equals a positive.
Louder. A negative times a negative equals a positive. Louder.
A negative times a negative equals a positive.
Why?
Stand and Deliver. Classic film. If you haven't seen it, you absolutely should. It's timeless. Anyway, yes, in a lot of situations, parentheses mean multiplication, but not all situations. In fact, when you're dealing with an XY coordinate, for example, if I'm looking at the point on the number line, 1, 2, well, there's a set of parentheses that I'm using that isn't about multiplication, right? So I try to veer away from whenever you see this, you do that, because all notation gets recycled at some point or another. So there will be lots of times when we see parentheses where it doesn't mean multiplication, just throwing that out there. For now, though, yes, every time we throw parentheses out in this video, we will be talking about multiplication specifically. So there are a lot of ways to understand multiplication in general and multiplication of negative numbers specifically. And this can be a big stumbling block for folks. So as you can see, I've got several different ways of understanding this, and I'm going to run through all of them. So I'm going to start with the example that Senor Escalante gave in the scene we just watched. Okay, he said negative times a negative equals a positive. Let's move this over a little bit. I'm going to be looking back at this example several times over the course of this video in the hopes of tying together all the different ideas that I'm going to be trying to get across to you. Okay, so let's start easy, all right? If you're a fan of good old-fashioned memorization, here's the rules. If you have a positive number times a positive number, no comments about what that looks like, please, you get a positive number. Remember, those parentheses in this context mean multiplication. Okay, if you have a positive times a negative, or because multiplication is commutative, which is a word that we've touched on before, but maybe haven't fully defined yet, I'll save it. But if you have a negative times a positive, in both cases, you get a negative. And as Senor Escalante said over and over and over again, and as I hope you will say over and over and over again as you think back about this video, as you're studying, or as you're trying to go to sleep tonight, a negative times a negative equals a positive. Okay? That's all you need to know in this video. This is just the facts, okay? If you have two positives or two negatives and you multiply them together, your answer is positive. If you have a positive and a negative and you multiply them together, regardless of which order they go in, your answer will be negative, okay? Now, before I record these videos, I ask my friends on social media to help maybe share with me what ideas or techniques or mnemonic devices that they've used in order to help them remember these sorts of rules. Okay, and one friend came up with this fantastic example that I'm going to show you right now. So imagine you have this sort of pyramid, and on the bottom you have two negatives, and on the top you have a positive. Okay, now you already know that if you take a positive and a positive, it's going to be positive. Like, we already know that. That's not a thing that we need to be concerned with, right? No sense in coming up with new rules for stuff that we already know. But what if we have a positive and a negative or two negatives? The pyramid will show us what to do. For example, if I multiply a positive times a negative, well, my result is negative. If, on the other hand, I have two negatives, well, in that case, the answer is positive. I didn't use this particular model, but I really like it. I think it's handy, it's visual, and if you can remind yourself to write it down on the top of your exam whenever you're dealing with positive and negative numbers, it can be very helpful, at least until you get fluent enough to where you don't have to really think about it anymore. So hopefully it makes sense that if you have a positive times a negative, it equals a negative. We're going to talk about it anyway, but it usually makes some sort of intuitive sense. The part that really trips up most students is this bit right here. This negative times a negative equals a positive thing. The thing that we've been chanting this entire episode. And we're going to cover all of that and more. Don't you worry. Let's do this thing. Okay, so back to the beginning, we talked about the rule with a handy mnemonic. So we've done this bit, and again, going back to our original problem, this negative 2, we can interpret this negative 2 here. We can interpret this as -1 times -2, okay? That is a correct way of interpreting this. Anytime you see a negative number like -4, that's the same thing as -1 times 4. Okay? So if we're looking at this just from a strictly rules-based, I just want to memorize formulas kind of perspective, you can see this negative parentheses -2 as -1 times -2, and let's say it again together, a negative times a negative equals a positive, right? Right. Okay, so let's take a look at the next thing. Multiplication as repeated subtraction. I really like this because it really, it connects well to what you already know about multiplication, and you'll see what I mean in just a moment. Okay, so let's section some space off here, and let's talk about the problem 3 times 4. Okay? Don't worry, we're going to get into negatives soon, but I think you're going to see where I'm going with this. Now, 3 times 4, when we're young, we're taught that a multiplication is just a repeated addition. That is a valid definition of multiplication. Multiplication is a little bit broader than that, but let's work with it for now. If we say 3 times 4, basically that means we are going to take the number 3 and we're going to add it to itself 4 times. Right? 3 times 4 is 3 plus 3 plus 3 plus 3. It is 3 4 times. I hope I haven't lost anybody yet. But the opposite is also true, right? We can also say that 3 times 4 is 4 3 times. Right? So this is all very interesting, I'm sure, and the answer's 12 either way. Happy face. But let's mess things up a little bit by throwing a negative number into the mix, okay? So if I say instead, let's go with purple. 3 times -4. Now you see how I'm using this x again as a multiplier? You can tell, hopefully, that it's a multiplier and not an x because I'm trying to make it very small and in the very center of the numbers, as opposed to an x, which would like be a full-size letter. Again, the thing about math is sometimes notation is repeated. So when it comes to these x's, just make sure that you are clear about your intentions when you use it. So 3 times -4. Well, we've got a couple of ways we can look at this. We can look at this the very same way that we looked at this first one. Okay? Just because we have a weird negative number, that doesn't change the fundamentals of how numbers work. Okay? So we still get -4 plus -4 plus -4. That's the definition of multiplication, right? Just -4 plus itself 3 times -4. So we get -12, right? We already talked about addition and subtraction of positive and negative numbers. So hopefully the addition here isn't too difficult. So what about looking at it the other way, though? In this problem up here, we have this 3 times 4, we could do it in either of 2 different ways, right? We could say it was 3 4 times or 4 3 times. So let's really think about this. If I have a 3, and I'm trying to figure out what to do with it, what is this -4 times 3 talking about? With 3 times 4, we are adding 3 4 times. It stands to reason that with 3 times -4, we would be subtracting 3 4 times. So instead of adding 3, adding 3, adding 3, we're going to subtract 3 4 times. Once again, either way, our answer is -12. Happy face. So if we think of multiplying by a positive number as repeated addition, which again is kind of a limited definition, but it works well for our purposes right now, then we can see 3 times -4 as repeated subtraction. Now, again, when we have a negative times a positive, like the other way around, again, multiplication works the same way in both directions, so I'm not going to bother giving you an example of a negative first, then times a positive. It's just the same thing, right? But now we get to the really confusing bit, the part that really kills most students, and that's the fact that -3, and I'm going to put this in red because everybody is so scared of it, -3 times, now I'm using a dot for multiplication. Again, I tend to go back and forth between the different notations, times -4, and what's that equal? Now, this is a really weird kind of problem, and we're not used to thinking this way. Even thinking in terms of surplus and debt doesn't really extend to multiplication of numbers, okay? We're not good at visualizing this sort of thing. We know from our rules, though, that the answer is going to be +12, right? A negative times a negative equals a positive. But why? Well, let's think about it the same way we thought about 3 times -4. Again, the fact that there are 2 negative numbers here should not intimidate us whatsoever. They're just numbers. If I am taking -4 and I am multiplying it by -3, well, we just said before, in fact, let's use this second example right here, where we took this 3 here, and because it's being multiplied by -4, we, in essence, subtracted it 4 times, right? We took that 3 and we went minus 3, minus 3, minus 3, minus 3 4 times. So let's do that exact same thing again with this new, seemingly different, but not really different problem. We would say minus negative 3, right? We take the first number, the whole first number, whatever it is, and we are subtracting that 4 times. That's what multiplying times negative 4 means in this context. So, minus negative 3, minus negative 3, minus negative 3. Well, this should look really familiar. In fact, it should look exactly like what we had at the very beginning. This minus minus 2 ended up being a positive 2, right? A negative times a negative equals a positive. So, all of these minus minus 3's, well, they all become plus 3's, which is where we get our answer of 12. So having a negative times a negative equals a positive is the only thing that we could have done that fits with the rules of arithmetic that we've written so far, right? We only have a general understanding of arithmetic at this point. We are still building as we go, but if a negative times a negative was somehow still a negative, it would not fit, it would not sync up with the other rules that we've made or discovered or created in our math journey so far. So that's all well and good, and I hope that that was understandable. But I have other ways to look at this in case you're still confused, and I would not blame you at all if you still were. Negative numbers are the first time that you're really exposed to something that is truly outside of physical realm. Like, I can tell you about digging a hole and filling in the hole and debt all I want, but it doesn't make negative numbers themselves any easier to actually visualize. So let's see. We did multiplication as repeated subtraction. That was good. Let's talk about these two sort of together, negative as an operator and grammar. I'm going to move over to the right side here. In order for this to make sense, we're going to stop looking at the negative sign as negative. Stay with me. And we're going to instead think of it as opposite. Okay? Not a huge difference, but opposite. So yes, there are positive numbers and there are negative numbers, and this symbol means the opposite of whatever else you see. Okay? So if I say negative 2, well, it certainly makes sense that the opposite of that would be positive 2. We don't put a plus, but I'm going to put a plus there anyway, just so that you can see it. That would be the opposite, right? The opposite of a positive is a negative. The opposite of a negative is a positive. Okay. So what if I have the opposite of an opposite? There's only two options, right? There's positive, there's negative, and you're just kind of jumping back and forth between the two, right? So if I start in a negative place, and then I go to the opposite place, I end up positive. Again, this is kind of a more wishy-washy, wibbly-wobbly way of looking at it, but if you see the negative as a thing that's being done to the number, as opposed to a part of the number itself, maybe that'll help you out. Look at it as this negative is taking this 2 and making it opposite. So when you make it opposite twice, it ends up right back where it started. I don't know. I hope that's helpful. Ah, yes. Okay. So the last thing I want to cover today is something that I'm probably going to end up calling back to later on in the year because we haven't talked yet in this course about things like reflections and translations and dilations and all of those ways of manipulating shapes to change their position and orientation and size. But I do want to drop this idea into your head like a little seed in the hopes that by the time we get to this point later on in the course, it will have maybe sprung a couple of little roots, okay? Here's how I see multiplication of positive and negative numbers. Okay, so I'm going to go down and to the right here. I'll set up some boundaries. Now, I look at this more like a number line, like I said in the last video, right? I love my number lines. So here's my number line. And here's x equals 0, all right? And I'm going to say 1, 2, 3, 4, 5, and negative 1, 2, 3, 4, 5. And this is where I insert a bit of footage that I'm going to take in my bathroom where I'm talking to the mirror. So what I want to demonstrate here is the relative distance between me and my reflection. Okay, let's consider that I, Professor Cunningham, the obviously good Professor Cunningham, am on one side of the mirror, and my obviously evil and horrible twin, the nega Professor Cunningham, is on the other side of that mirror. Now, if you look, as we get close to each other, well, if we're actually on the mirror, then we are actually touching, right? We are 0 distance away from each other, me and my image. But as I back up, now I'm 2 feet away, now I'm 3 feet away. My image backs up at the exact same rate as me, to the exact same distance as me. So if I'm standing now approximately 4 feet away from the mirror, my image, the negative Mr. Cunningham, is on the other side of the mirror, also 4 feet away, very much like positive 4 and negative 4 on the number line. Let's say I'm standing 3 feet away from my mirror. Okay? Let's say I'm standing 3 feet away from my mirror, and my mirror is at x equals 0. So let's see if I can draw this without making a horrendous mess of it. There's my bathroom mirror, right there at x equals 0, okay? So if I'm standing 3 feet away from the mirror, it stands to reason that my reflection, if my reflection was a real person in a real place instead of an optical illusion, blah, 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 would be about, not about, exactly 3 feet from the other side of the mirror. So when I think of positive and negative numbers, I think of jumping from one side to the other of the mirror. The farther away you are from your reflection to start, the farther away you will be when you land on the other side, right? So if I was instead 5 feet away to start, well, then my reflection would be 5 feet from the other side of the mirror. So I see the negative sign as a reflection across 0. Okay? Once you say negative, you are essentially swapping places with your reflection. And it works the other way as well. Let's back up. It works the other way as well. If someone out in reflection land, someone who's maybe a little bit less happy, I don't know, starts at -3, well, then their reflection will be at x equals +3. And then once you have determined the correct side of 0 that you're on, you can actually multiply. And I'm going to show you what I mean right now. So what if I wanted to do something like 3 times 2. Yes, I know it's 6, okay? But I want to do something like 3 times 2, all right? Now, here's how I see multiplication. It might not be the same way you do, but I think this is going to be a good lesson for you to keep in mind when we start talking about scaling, because it turns out that this kind of multiplication, this multiplication of stretching, is going to show up again and again and again over the next 3 years of your math career. So listen up. I look at this as, okay, so if I'm standing at x equals 3, okay, there are 1, 2, 3 feet or whatever between me and the mirror, between me and 0. When I multiply by 2, what I'm essentially doing is doubling the distance between me and the mirror, me and the origin, okay? If I was multiplying 3 times 3, I would triple the distance and get 9, right? If it was 3 times 10, I would take the distance and multiply it by 10 and get 30. So when I look at multiplication, I think of it as a stretch or a compression away from 0. So what if we have a negative number? What if we have 2 times negative 2? Okay? A negative times a positive. Now again, you may have already memorized the fact that this is going to be negative and that the answer is -4, and that's great, but stay with me anyway. So we start at 2. I'm just going to put a star this time. Okay, we start at +2. Now there are 2 things happening here. Okay, this -2 that we're multiplying by, that's doing 2 things. The 2 is doubling the distance from the origin, right? Because it's times 2, it's doubling the distance. If it was 3, it would be tripling the distance. If it was 1/2, it would be half the distance. And this negative means we're reflecting into mirror land, or if we're in mirror land, reflecting out into positive land. It's a ticket from positive to negative or negative to positive, right? Now, the question becomes, do we double first or do we reflect first? And the answer is it doesn't matter. I'm going to go ahead and double first. So let's see, there's 1, 2 spaces from the origin to the star. So to double that is 3, 4. The star goes there at 4. But then we reflect it over the mirror. -4 is the answer. 2 times -2 is -4. So here we have several ways to go about thinking about these positive and negative numbers and how they interact via multiplication. That's all I got on the multiplication of positive and negative numbers. Please do leave your questions in the comments. I would love to answer as many of them as I can. Next week, I'm going to be taking on division and a natural consequence of division, the dreaded fractions, bane of students and parents and teachers the world round. But actually, they're not that bad. Find out why next time. I'll see you then.